Hi everyone, I welcome you to the presentation of this lecture on types of DC generators. Okay, so in the previous lecture we discussed DC generators. We did some calculations there concerning the principle and the EMF equation. This is a continuation. We'll be talking about types of DC generators. So DC generators can be classified into two groups. These being, we've got what we call self-excited generators as well as separate excited generator. So for this presentation, we're going to look at separate excited generators. What is excitation? Excitation, by definition, is basically the process of supplying current to the poles of a machine so as to magnetize them. Okay, so the process in which we supply current to the poles of a machine, that is what we are calling excitation, and it can be done into two. You can either bring an auxiliary exciter that makes it a separate excited generator, or a machine can excite itself. That one is called self-excitation. As I said, we'll be looking at separate excited in this presentation. So separately excited generators, they look something like that. So you have our machine, which is this one. So this is our machine where you have your load and the armature. Excitation is supposed to be done in the armature, but excitation for this one is not done in the armature itself. You've got an external source which is exciting that one. So this is a circuit for a separate excited generator. It looks something like that. Okay, so with this, we shall look at governing equations. So you realize that in the armature there is the resistance, which we're calling the armature resistance, and there's a current coming from the armature there going to the load. That current is called IA, armature current, and there's a current going to the load, which we're calling load current. But as you can see, these are in series. Therefore, we can simply conclude armature current and load current, they are the same for a separate excited generator. So let's discuss some governing equations. So IA, which is the armature current, is basically the same as the load current. And generated EMF. So for generated EMF, for all of the machines we discuss, it will basically be a summation of all the voltage drops in that circuit. So in here, what voltages do you have? You have a voltage in here in the armature. That voltage is a product of the armature current and the armature resistance, which is this one. And there is another voltage there, the voltage at the load there. So it's a summation of all the voltages actually in the circuit. It's what we'll be calling generated EMF. So for this one, we have two of them. There is a voltage generated there, which is IARA, and there's a voltage at the load. When you do those summation, you're going to have the voltage which is generated by a machine, and it's given by that. And we've got some powers. We've got power output. Power output is measured at the load there. It's basically a product of the voltage at the load and the current going to the load, which is this one there. There is another power which is inside the armature. This is the power generated, and power generated is basically the generated voltage, which is this one or that, times the armature current. So we'll be multiplying the armature current because we are generating this power inside the armature. So power generated is given by that one. Okay, so the next slide, we're going to look at some examples. Okay, we're looking at an example. So the question reads, a generator is connected to a 60 ohm load and the current of 8 amps flows. If the armature resistance is 1 ohm, determine the following: terminal voltage, generated EMF, power output, as well as the generated power. Okay, so on our solutions, we have that. We need to carry out data analysis. We analyze whatever we've been given. So we've been given the resistor connected to the load, which is 60 ohm. We've been given the armature current, which is 8 amps. Of course, for a separate excited, this is the same as the load current. They've given us the armature resistance, which is 1 ohm. So for the first one there, they're asking us to find the terminal voltage. Terminal voltage, we said it's found by that. Terminal voltage is basically the load current times the load resistance. But the load current and the armature resistance are the same, so it's basically that. When you're using the armature, you have is that one, the load resistance is that. After multiplying, we are getting 480 volts as our terminal voltage. Generated EMF is given by terminal voltage plus armature current and the armature resistance. When you do your substitutions there, you're going to get terminal voltage is 480, the one we've calculated. Armature current, it's 8. Armature resistance is 1 ohm. Do your computations, we are getting 488 volts. Power output is basically the voltage at the load times the load current. Voltage at the load is 480, terminal voltage. Load current, which is the same as armature current, is 8. So doing a multiplication, you are getting 3,840 watts as the power output. And we've got the power which is generated in the armature. This power is given by the generated voltage and the armature current. Generated voltage is 488, armature current is 8. When you do your computations, you are getting 3904 watts as the power generated. So this marks the end of my presentation on separate excited generators. In the next lecture, we're going to discuss self-excited generators.